Yes, the Mac here again. Mac frames are going to be specified in the 802.15.4. It is like this. Mac format is going to be here, 802.15.4. So we can able to see that the frame is there here. Again, it is going to be, first is a frame count, second is sequence number, third is destination pan address identifier, then destination address, source pan, pan identifier, source address, then the frame payload is going to be there, then the frame checkpoint or check sequence will be present. So here you can able to see that from the physical layer, that is a physical frame, preamble, start of the frame delimiter, frame login, frame length, then the physical payload physical payload is divided into Mac frame. The Mac frame here, the frame control is going to have 2 bytes, sequence number is going to have 1 byte, then addressing fields is going to have 4 to 20 bytes, then the frame payload for this Mac payload is going to be a variable length. So till this point that the Mac header is going to be considered. Then Mac payload is nothing but a frame payload it is going to be. Then there is a Mac footer is there. So which is going to have the frames check sequence. That's of 2 bytes. This is basically used for the data frame, handles all transfers of the data. Beacon frames are going to be used for the transmission of a beacon from pan to the coordinator. Then acknowledgement frame is going to be used for confirming the successful reception of the frame. So here sequence numbers are going to be used for that purpose. Then Mac command frame. So here it is responsible for the control communication between the devices. Okay. This frame broken into 3 parts. One is Mac header, payload, and footer fields. So as those things only I have discussed over here. Next is individually specifically that it has been addressed over there. Same thing it is going to be frame control, sequence number, and addressing fields. So in the frame control defines the attributes such as frame type, addressing mode, and other control flags. The sequence number, it indicates the sequence of the indicator for the frame. Next is addressing fields, where the address is going to be specified for the pan identifier. The field is going to be now again the Mac payload field varies by individual frame types with the maximum of payload of 127 bytes, and also depends how the 16-bit short address is assigned to the devices. Here you can see that beacon frames have specific fields and payloads related to the beacons. Mac command frames have different field present here for this. The Mac footer is going to be there, that is frame checksum or check sequence we can say. It is a field is nothing more than that frame checksum, check sequence, so called as FCS. It is a calculation based on the data in the frame that is being used by the receiving side to confirm the integrity of the data in the frame, whether this much it is there, whether you receive it or not. So that it is the confirmation integrity for the data set, that frame. Now let us move towards the topology of 802.15.4. Here it is going to use the star, peer-to-peer or mesh topologies. So mesh topology ties together with the many nodes, but this allows the nodes that would be out of range if trying to communicate directly to device integrity or nodes of the towards the transfer communication. So that time it is going to be used. 802.15.4 PAN should be set up with a unique ID. So here in the diagram that it is going to be specified here, for mesh network it is going to be, there is a PAN with a dark color, circled one. PAN is called as a PAN coordinator. Then full function devices, FFDs, partial one, and reduced function devices, RFDs, are still lesser dark. So that indicates that the PAN coordinator is going to be there. In this, here is the PAN coordinator. Here is the PAN coordinator. It is the minimum of FFD acting as a PAN coordinator is required to deliver the services that allows other devices to associate and form the cell or the PAN. A single PAN coordinator is identified with the PAN ID, that is PAN ID1. So FFD devices can communicate with the other devices, whereas RFD devices can communicate only with the FFDs. Now you see here, these are the PANs, but FFDs devices can communicate with any other devices. FFDs can communicate with any other devices, but RFDs devices can communicate only with the FFDs. So here, this one, this is RFD, this is RFD. So these two can communicate only to the FFD, not with the FFD. And FFDs can communicate together, and for the PAN, one of this one will be the PAN. Activity 802.15.4. It uses advanced encryption standards security for this. So here with a 128-bit key length as the base encryption algorithm for securing its data and also validates data that is sent. So for this, there is a communication security field format is going to be there. Frame format is going to be given here. So the validation is accomplished by the message integrity code, that is MIC, message integrity code, which is calculated for the entire frame using the same AES key that is going to be used for the encryption. So MIC and AES both are going to be same. AES is a block cipher, which means it operates on the fixed size blocks of the data. Now you can see in this the security features of the 802.15.4 slightly consume some of the payloads. Using this security enabled field in the frame control portion of the 802.15.4 header is the first step to enabling the AEC algorithm or encryption. So this field is a single bit that is going to be set for one for the security. Once the bit is set, the field called the auxiliary security header is created after the source address field. Now you can see there is a auxiliary security field is created, but when on the frame control. Now you see that when this security key is going to be set, there is next is the sequence number is there. Frame control is 2 bytes, so sequence number